So this session is regarding singer. So you must have imagined whenever we are starting any project, right? Many of the engineers ask which database should we use. So the first thing is we always prefer to understand what is the architecture or what is the system design um, for choosing the databases. What is the logic behind this database and why not that? So to solve this question of choosing the database, first we need to understand something called as um, uh, we have to understand related to the data, whether the data is a structured data or semi-structured data or a fuzzy data. So let's understand what is structured data, what is what is the what is unstructured data, and what is semi-structured data. Basically, these are the three types of data where usually the interviewer asks these questions all about. So when we say structured data, it is something fixed schema. It has a fixed schema. For example, you can say it as user having user ID, user having its email, user is having its phone number. So those kind of is called as a structured data. One second, just so those kind of data is a structured data. Then we have something called as defined columns, or there are something order ID. For example, you order ID which is mapped again to the order ID is mapped again. Order ID is mapped to the payment system. It is mapped to the amount. So order ID is mapped to payment. Payment is mapped to amount. Then amount is mapped to status. So this is something called this is something which you can say a structured format, a structured data. So the structured data consists of a fixed schema or a particular relationship where there is a strong relationship between what you're providing. Like as I said, mentioned about the order ID. Also, I mentioned about the user ID having a phone number, user ID having phone number, having email ID. So this is kind of something which is having an email, having a name, having SSN number. Um, this is something called as a structured form. Now, what is called as semi-structured data or unstructured comes later on. We also have something called as semi-structured data. What is that? So here basically you have a data with different types of attributes. Now, what is that all about? Semi semi-structured data. So data which consists of in a JSON format. For example, you have a product. You have a product and product name is so the name of the product is shirt, and the brand of the product is Polo. Then the size of the product is medium. Color of the product is white. So this is something like a JSON form. You can give this in a form of a JSON, right? Um, so this is called as a semi-structured data where you can have lots of attributes to one particular, one particular product. And these attributes can be stored in a JSON way. So this is called as a semi-structured data. So what is unstructured data? Unstructured data usually consists of images, it consists of videos, consists of PDFs, then it consists of audio files. So these is something related to the data. So when we are doing any choosing of database, when a question is asked, like we have to choose a database, we have to understand whether our data is based on structured data, semi-structured data, or unstructured data, on top of which we can we can select our database. Now let's get into the more deeper of choosing database. Suppose let's talk on the structured data first. Suppose we have a use case where uh, usually where the common use cases for the structured data are payment system, right? Payment system, or we have banking platforms. So in transaction A and the another transaction is coming from a B, and then this has to get reflected in the database that this transaction has occurred. So this is something called as a structured data. You cannot have any fuzziness in the data. You cannot have semi-structured data. You cannot have a lot of attributes into this. It's just an account A versus account B, and this should have reflected. So for this kind of data we are using RDBMS, that is relational databases. Now this relational database, when we are using these relational databases, we are also using something called as ACID form. What is ACID form? ACID is atomicity, consistency, isolation, and duration. This is the full. Now why this is used for the structured data? You take an example, why it is used for the structured data with payment system use case. Basically, ACID is used mostly in the payment system, banking system, inventory management, where your data is kind of a lot of important, and you need to have that um, you need to have the A to B connection of each data. So there we use RDBMS with ACID. Now, what is ACID exactly? The atomicity. What is atomicity? A stands for atomicity. That means a transaction must fully succeeded or fully failed. That is called as atomicity. Consistency, it has to be consistent everywhere. Isolation, it should not be like user A is transferring some amount user B to the account B, and account B is also transferring. So these kind of parallel calls or this kind of should not happen. There should be an isolation. Once one transaction is completed, another transaction will start. Then durability, or that is something like one transaction is committed, then that should not be lost somewhere. It has to be reported, or it has to be accounted in the database. So that is something ACID, which is used mostly for these use cases like payment system, bank, inventory management. So in your interview you have to understand like what is the use case all about. Suppose the use case is order placement, there also we need something very strong as the user ID. Oh, right. So this is something which is very structured, very consistent. It cannot be changed, and it should be succeeded or failed. It lagging in between. So that is where we use RDBMS, or we use MySQL data, or we can use MySQL, Oracle. These are the common databases. You can use anything, but I'm just giving these as I've used this PostgreSQL. These are the databases which you can use it. Now let's real-time examples, like you're creating any payment transfer, or you're creating any order system in Amazon. Then these databases we can use. Now, there are also some examples. So these are the examples where we use ACID. Now, there are some other examples where we have structured data, but we do need ACID. So, what are those? Let's see those examples. So structured data without ACID. So this is something, these kind of uh, yeah. So here in you can get examples of semi-structured data, or you can also get something like user profile information or address books or preferences, where user profile information, where what is the address of that user, what is the address of that user, or what is the email ID, what is the address of that user, complete address, like zip code, pin code, country ID. That information, if you need to provide, then that comes like, you do not need atomicity. Address can be changed, it cannot be consistent. People have rental, so they will change the addresses. So also, even if it is um, even if it is not completely succeeded or completely failed, it can stand in between just by giving you the main address format. Also, there are something like preferences of candidates, like they want preferences only in the account management, only in the HR management, or in the engineering management. So these preferences are not like a fields. So for such use cases, you always can without ACID databases, and those databases can be RDBMS. Here you can use RDBMS relational databases, plus you can use NoSQL databases as well. So it depends more on, depends on read and write scale, or correctness of the data, whether you want exact corrected data, or you are fine with not having that much correctness. Now let's talk on semi-structured data, lots of attributes like shirt size, or you are in the Amazon, what a system design of Amazon, and there you have product name, or you have a milk, someone buying a milk with a quantity. So milk has a attribute of quantity, like in liters. Then it will also have another attribute of brand, like which brand of milk you are using. Another, it might have an attribute of expiry date. So these are something which can semi-structured data, where you need a sparse column, frequent schema changes, and complex joins. So trying to force the tables into that result, and for which, so here you have this kind of columns, you need to maintain little bit about no sparse column, not much. Frequent changes can be there, like quantity can be changed, expiry change. So these are frequent changes, and thus for this you need to have something called as document databases. So example of document databases are MongoDB. So these are very useful, popular tools. Then couch databases. Why MongoDB? Because you can have a easy query also on these databases. They store these basically these databases store JSON data, JSON documents. Plus, it is allowing flexible schema structure for the JSON. Also, easy evaluation and natural modeling. Like you can, have a lot of queries you can ask, as well as you can have an easy evolution between that. And it is a user guaranteed content. Like, when you are asking any questions, user are guaranteed with answers, because it is already stored, like product catalogs, it is already stored. So these can be used on semi-structured data. And when you have a semi-structured data, you can use MongoDB. When you have transactions or any important things happening, you can use something like SQL, MySQL, Oracle, PostgreSQL. Now what about unstructured data, like images, videos, and audios, or PDF, right? So this is something this is something, this, this is unstructured data, but this can be captured in the images, or these are large files, right? These are large files. So the chapter of this is related to storage, right? So the storage is not in the database. Basically the storage happens in S3 bucket. So we'll have this unstructured in two format. This is one format where we will use S3 buckets for storing. So the storage is in form of S3 bucket. Plus we have storage is in format. Okay. So storage is in form of S3 bucket. Plus we can also use CDN. Always storage of this big files or large, we need CDN, that is content delivery network. Now what is this like? If you need to pass on this files to the different geographical servers, then we use which is one of the important. Whenever you have whenever you are creating any use case which are related to the storage of images or storage, and something like in WhatsApp, you have these images and you are sending images to in during Christmas vacation, Merry Christmas. These images, these files or any songs, those can be stored in S3 and CDN. You can pass it on to different geographical servers if you want to pass it to different friends which are located internationally. So these are something can be used, and this is a different topic altogether, but this is one of the type of storage, and we are talking about all about the storage. So let's talk about different about unstructured data. um, there is one more part which where you have ever increasing data, right? So let's talk on that, ever increasing data. So what is the meaning of ever increasing data? For example, let's take Uber, right? We have a lot of drivers coming in, right? And these lot of drivers have different types of locations, right? We have to track all the locations. And now what is happening, this is ever increasing, drivers are ever increasing a lot. Every weekend you have new drivers, right? So the data of Uber is now ever increasing data, and with known queries, and with known queries. What do you mean with known queries? Let me write that. Usually with when Uber start any query, any user, which driver is at Chicago location. These are specific queries which are always being asked, and the data is always increasing. There are a lot of drivers, there are a lot of locations which has to be tracked. So in such cases we have to use columnar databases, and these databases are like most suitable database for columnar is Cassandra and HBase. Now I have always used Cassandra because it is very easy to deploy, and it will give you different, for query purpose also it is easy when you're querying such kind of even Amazon, right? These are there are the use cases like Amazon, where one of the use cases Amazon, where you have orders placed, uh, and supplier adding more items into Amazon, more items on Amazon site. So this is something like a supplier will always do that because they have a lot of items to add. Plus there will be a lot of orders which will always be placed. So these are something which cannot be stopped. It is an ever increasing data. So for that we have to use something called as a columnar databases, which is Cassandra, which is very easy to query, or we can have HBase also. Why these works? You have a question, you will have a question why this only databases works. So these are extremely high write throughput, they are horizontally scalable and designed time based or partition based access. Now there is on top of all these databases which we are talking, is something called as caching. Caching is very important when it comes for choosing the database or when you're thinking on the database. So any system design question when it comes for databases, you should always think on caching, because same database you are querying 100 the same query, that is not a useful scenario. That will be an expensive for each remote service. So for example, I'll give you, we have different types of remote servers. So we are a third party service, and this is happening, same get call is happening lot of times. So in such cases, we can cache the response so that we do not have to call so many times to the same server. So for caching, we can usually use Redis cache, that is mostly used and tested database which we can use. And how this caching works, basically in the caching, we have key and value pair. So what exactly is key? Key is like your queries which you are asking, where clause, these are the queries, and value is basically the responses which you get from the where clause. Memcache is also being used, but this caching is not something like a source of a truth. This caching is for some period of a time. So this is not a source of a truth. So you still need uh, the databases to store. Still, we need the databases to store the logic, store the data. Basically caching is just for some period of a time. Now when I talk on blob storage, this is all blob storage like images, videos, and where we need a CDN to reduce the latency, to improve the reliability. We use CDN and S3 bucket hand in hand so that we can save the large files and we can transfer it to any of them whenever required. So there is something also called as time series database. So we spoke on relational databases with ACID. We spoke on semi-structured databases with document databases like MongoDB. We spoke on ever-increasing data like for Uber and Amazon use cases, Cassandra. Then blob storage. Then we have this part of caching. Now let's see something which is time series database. Now what are these time series database, right? So time series database is mostly used in Grafana when you want to calculate the performance of any performance, or you need something like time based append only or need range queries. For example, CPU metrics, you need a CPU metrics, or you need to know what is the memory usage or what is the application latency, right? Then memory usage, these are the use cases, I'm right. Like you need to know what is the memory usage, you need to know CPU metrics, right? Then for such things you need time series database. So what is time series database? Like once one it is done for T1, then next commit is saved for T. So it is based on time, and this is like heavily used in Grafana. So basically time series database, whenever you have use cases related to CPU metrics or any memory usage, or application latency, how much is the application latency. Then we can have these time series database, and this is the example of time series database. When one commit is done for T1 and another is also there, then it is based on the time, and there we can use this databases. Like the more often tools which are used are open time series database, that is one of the InfluxDB, Prometheus, Grafana. These are the tools which we use. Then we have this analytics and reporting. Now, what is analytics and reporting? Let's see that. This is so basically, there is lot of more data. You have a large data, right? But you have large data and you have to create historical analysis. Like Amazon also have a lot of data, and you have to create like a user, what is the history of the user, what all products it is being or he's being ordering. So then for that purpose you need reporting tools, right? You need to understand the trends, aggregations. So for such purpose we use data warehouse. We use something called as a data warehouse, and the main data warehouse is Hadoop, or you can also have BigQuery or Snowflake. These are the main examples. Like how many users, for example, you have a use case where you ask a question, how many users brought uh, how many users brought sugars. Now sugars have different alternates. Sugars can be you can have erythritol, or you have sweeteners. So how many users brought different sugars? So sugars can be of different brands, sugar can be of different suppliers, sugar can be an alternate of the sugars. So for that, how many users buy uh, different sugars? So for such reporting, we need something as popular tools like Hadoop or BigQuery. So you understand this. We need to understand the reporting. Like Hadoop is a big database which we can use it and understand this query. So any use case which comes which are related to large database, large querying, then we can use Hadoop or data warehouse. So a real system. Let's talk about real life system. Let's see a scenario where we can use and all of these in one scenario. Like for example, in Amazon, okay, for inventory management, right, for active users. As I said, for Amazon inventory management, with active users, we can use RDBMS, Cassandra. Where can we use Cassandra? For Amazon, just for an Amazon, where we need to have something like order, um, we need to have the order placement, right? When we are placing the order with a particular attributes, then we can use Cassandra. Then we can use MongoDB. MongoDB is a document database where you can maintain the metadata of the product. So you can have product metadata, right? Then you can use Elasticsearch. Again, Elasticsearch is something like a text search. This is also very important part during your system design interview. Like any users searching with a text, like sunscreen. I need a sunscreen. They made a mistake in spelling of sunscreen. Instead of sun, they are writing SON. So for that there is something called as fuzziness, and this can be achieved with the Elasticsearch. So Elasticsearch can also be used on the Amazon for searching the products. Then we have Redis for caching. again same queries are asked, which sunscreen is good in New Jersey. So the same queries can be asked a couple of times, so you response is stored somewhere. Then we have S3 plus CDN, where you can have media uh, can be stored, like media, like many images reviews comes with the images, so those can be stored in S3 bucket. And data warehouse, you can use it for analysis purpose. So these kind of question, when a interviewer is asking, like build an Amazon site, so you can use all the databases for various different scenarios, for various different use cases. And this is something called as polyglot persistence, where the best systems are not built with one database, but it is built with clear intent of use cases, where to use what. And this is all about choosing the database, and each database exists for optimizing the correctness, optimizing the scale, optimizing the performance, and also optimizing the cost. So this is all about it, and you should understand where to use this asset. You should understand the data very well to get into choosing of the databases. Thank you all for Thank you all. If you have any questions, just let me know.